Now we'll be looking at the Martian Life question, which is the Division 2 third question. So the question is, it's 2050 and Elon Musk has successfully colonized Mars, and due to lack of oxygen, we have formed colonies of glass domes. So the number of colonies we have is N, and the number of tunnels we have is M. So the tunnels are basically used to communicate or travel between N and M. Um, So tunnel I acts as a one-way transport through from colony PI to QI. That means there is a particular colony. Two colonies are connected with the help of a tunnel, and it takes certain number of minutes to travel through it. So after reading this part, I'm sure you might have understood that this is a graph question with xi being the cost, and since this is a one-way route, now it is a directed graph. So there can exist multiple tunnels between two colonies. Hence, Pi is equal to Qi is also possible. That means this also means that we can have a self loop. Okay. So you as a mass inhabitant decides to tour through all the colonies. This. So you decide to start the tour from each colony one by one. Thus determine whether a tour is valid from each colony, and if it's valid, then print the time required for the tour when you start from the colony. Okay. So basically, what you need to do is let's look at a sample. Okay, so over here 4 and 4 are the n and m, that means the number of nodes and the number of edges, and these are all the edges. So one first node to second node, and the cost over here is 5. Second node to third node, the cost over here is 3, and so on and so forth. Okay, so we have a lot of other samples as well, but we are going to look at the first one only. Okay, to understand the basic implications of how to develop the logic. Okay, uh, okay. So over here, let's take the first sample. Okay, so yeah, so over here 1 is connected to 2, uh, and the cost over here is obviously 5. Okay, so 5. Okay, and 2 is connected to 3, 10 is the cost over here, obviously time to travel from second colony to third colony to first colony is 15, and traveling from fourth colony to third colony is 20. Okay, so what we need to do is we need to calculate how long it will take to start from here as well as return back to this node. So over here you can see that this is basically forming a circle. So if we start from 1, we'll travel to 2, then 3, then back to 1 again. Okay, so that is why all the outputs over here is 30, because sum of 5, 10, 15 is 30, and so time to travel through this loop would be constant for all these nodes. Okay, now if we look at 4, so they have returned -1 for 4 because 4 does not have any incoming edges. It has only outgoing edges, so that is why 4 will obviously return a -1. Okay, so looking at the question, so this is a directed graph, okay, DG, and we need to basically find out what is the minimum distance, right, or the minimum time taken to travel through a loop over here. Okay, so the first concept or the first thing which comes to your mind when we hear these two things are Dikshitra's algorithm, right? Dikshitra's algorithm is basically for a weighted direct graph, and it tries to calculate the weight. Uh, now, since Dikshitra's algorithm might require a lot of time to implement, right? Because it might take 10 to 15 minutes just to write the code for this part, and copy pasting code snippets was not allowed in the competition. So we'll try to solve this question with the help of another method. So let's go ahead and look at the code, and whenever we require explanation for a certain part, I'll jump back to the notepad. Okay, so let's explain the code. Okay, so over here first we are taking int nnm and integer a comma b comma c. First we are obviously accepting nnm. So nnm over here is 4 is the number of nodes and 7 is the number of edges. Okay, so based on that we have first also created a vector. So in a particular vector, what are we storing? This vector will obviously have the nodes. Okay, for example, if we have 10 nodes, so for that we have one vector, and for one particular vector we also have all the edges associated with it. For example, if we have a node numbered 1 and it has two edges, which is outgoing. Okay, so we are going to store this as a pair meaning we are going to store 1 over here, and then we, if this edge goes to 2 and another edge goes to 3. Okay, so over here we are going to store two pairs, 2, then after that followed by the cost. For example, if the cost over here is 1, so 2 1, that is one pair, and then 3. And if the cost over here is 4, then another pair would be 4. So with this, one node has two pairs associated with it, so that is, this is a vector of pairs. Okay, so we'll have to define one vector, another vector consisting of pairs, and each pair will be of integer type. So this is what we have written over here: vector inside a vector, pairs, int. So this is basically for our graph, and we have initialized it to 0. Okay, then after that we have accepted the input. Obviously we will have to decrement the value of a and b, since as you can observe over here we are starting with 1, but indices in our graph obviously begin with 0, so we also need to decrement this part. Now after that we are pushing the values of b and c. B and c, obviously what I talked about over here is this, that b and c is basically the edge which the edge is directed towards, or the node at which the edge is directed towards, and the cost or the weight associated with it. Now this is how we are going to solve the question. So we have accepted the input. Now let's talk about how we are going to solve the problem. So over here, first of all, you can see that we have used a priority queue. So why did we go with priority queue? So priority queue will be helpful in a scenario where we just need to find the minimum cost, right? So instead of using Dikshitra's algorithm, we can use a priority queue in order to store the weights and choose the least weighted node and move ahead and try to solve the problem after that. Okay, so that is, you can say, is a substitute to Dikshitra's algorithm. More or less a similar logic, but just a different data structure we're using. Okay, so we are running this loop for n number of times. Obviously I had mentioned earlier that we have to produce n number of input output. So if we have for example 4 nodes over here, so our output also should have 4. Okay, so that is why we are running this for n number of times. And after that we are iterating through each and every node which is connected to the particular node. For example, as I had mentioned earlier, if we are talking about in one we need to store how many edges does one have. So and then we need to push it to the priority queue. Okay, so we have already accepted all the edges, and we'll just basically be accessing the first element and all the edges associated with it and pushing it onto the priority queue. So this is what this pair of line means. Cool. We'll talk about where we use int and this use vector later. Now after that, after we have formed the priority queue, we need to check whether the size of the queue is not equal to 0 and run this queue. So basically we are running a loop till we have encountered or tested out all the edges. For example, if we have two edges, so we'll try routes from this edge as well as this edge, right? So until and unless we have completely run out of all the edges associated with this point, we'll continue to traverse the or run this while loop. Okay, so int pair q of top. So what this will return is, for example, if one has two edges associated with it, which is it is connected to node number 3 and it is connected to node number 4, and node number 3 is connected with the help of a weight which is maybe 5 and another weight which is 10. Okay, so what we need to do is it will be returning the higher weight. Okay, so over here the higher weight is 10. Okay, but should we really be returning 10? Right, we need to take the minimum amount of time, right? So for minimum amount of time we are calculating, we should have picked 5. So another method to resolve the situation is we just multiply this all the weights by 1. Okay, so whenever we are pushing anything to the queue, we are also multiplying the weight by -1. So in this scenario, when we needed to pick 5, we are so the two values inside the priority queue now would be -10 and -5, right? So again, -5 being greater than -10 would get picked. Cool. So that is how we are tackling with this scenario where priority queue actually picks a higher number, but we want to pick a lower number since we are calculating the least number of minutes. Okay. So yeah, so first we picked the one with the lowest weight associated with it and popped it out of the queue. And after that, for example, if one is connected to two with the help of weight numbered 5, right? So after that we need to traverse or associated all the nodes associated with 2 as well, right? If 2 is connected to 3 and 4 further, so in that scenario we need to add that to the queue as well, right? 3 and 1. So we'll have to traverse through all these nodes as well, and maybe choose the most optimal node on the way as well. So obviously after putting two or popping two, we also need to explore the further parts of the graph as well. So that is why we have created this for loop over here. So in this for loop, we are basically pushing the values or the nodes which are connected to the second value which we find, right? Temp dot second is basically the value which we have popped over here. So over here we are just basically pushing all the values or adding the values which are after this as well. So in case if 4 over here has 5 value over here and weight over here is 1, so weight associated with traveling from 1 to 4 would be 6, right? So what if we have another node which also has 6, right? So in that scenario it would get a higher priority since this was added before 1, okay, or before 4. So in case if you're wondering how are we exploring all the suitable diagrams, this is how we are doing it. We are doing it with the help of priority queue, and we just continue to check what is the smallest distance, what is the smallest distance, what is the smallest distance, and this continues to happen till we return back to the first node. So that is why we have also written this condition. That means after traversing through the priority queue, that means what is happening over here, basically if I have one, right? If I have 1 over here, so what would happen, I have traversed 1, so that would be basically be my first node, and after that I'm going to put 2 in the uh, priority queue because 2 is the only value which is associated with 1. So value inside priority queue right now would be -5. Okay, so yeah, this is obviously the smallest value and only value which is associated with 1, but still we actually need to so we don't have any value to compare it with, so priority queue obviously has only one value. Okay, and after that 2 is now pointing towards 3. So this is when this for loop will come into picture, and we'll also put in 10 over here, so 10 would then be added to over here. Okay, so when we are pushing something, we are also adding it over here. So basically we are trying to find out the total time taken to traverse till we return back to 1, right? So we need to keep track of the sum of time. So what we'll basically be doing is do a -10 over here. So total time taken to traverse between from 1 to and then to 3 would be -15. And finally we would check whether we have reached I or not. No, we have not reached I. So this would be my new temporary like this would become my new variable, and I would then push values of this associated with this over here. So I've just printed I inputted -15 over here or 3 over here and get a -30. Okay, now that I've gotten a -30, I've returned back to the I part, one part, right? So I just followed the nodes which I have one after the other. That means the node, I'm just popping the priority queue, that's it. Okay, so my priority queue initially had -15 and the node associated with it was 3. Okay, so initially my priority queue had -5 and the node associated with 2 with it was 2. Then after that it has -15. That means the cost required to travel till there is was 3, and after that my priority queue was -30 and 1. Okay, so now I've returned back to the first element or the first node. So in that scenario, as soon as I return back to the first node, I need to print temp of first equal to -1. That means the cost taken to travel through the entire graph or the entire loop. Okay, so I need to print it by -1 because initially, as I had told you, priority queue chooses maximum value. So we had multiplied all the values by weights by negative by in before adding to it, before adding it to the queue. So before printing as well, we'll have to multiply it by -1, and hence plus 30 would get printed. Okay, now we have basically understood how we would calculate for one. A similar situation would happen for two, right? Because this for loop will run for each and every node. So over here we have chosen I is equal to 0. After it becomes I is equal to 1, g of I would get chosen. G of I meaning the second node, right? Because we are decrementing here over again. So after that, after considering this, the same algorithm will be applied to 2, and after that the same algorithm will be applied to 3. Okay, so now we need to deal with a scenario where we are dealing with a node which is not receiving any what do we call edges. Okay, so in that scenario we'll have to create something known as a flag. Okay, so in case if we do not print or if we do not return back to the solution, or what do we call if we print, if we are able to print a solution till we have encountered. So if we are able to print a solution, we do not want to print -1, right? So yeah, over here if we are not able to find a solution, we are printing -1. So over here, since we are able to print the solution, we are making the flag as 1, and initially the flag was initialized to 0. Cool. So we also need to do another thing, and that is make sure, how do we find out ki we have actually run through all the possibilities and checked all the nodes and still we are not able to return back to 4. So that is done with the help of an array known, a vector known as used. Okay, so in used we go back to the we do not what do we call push or push values into the queue which we have already encountered. So in this scenario, if we see for 4 has just now encountered 3, right? So we would in 3 in used vector we would make the value for 3 as 1. Okay, and we have initialized all the values to 0. So we have 0 over here, we have 0 over here, and so on and so forth. So we have initialized the value of particular third numbered location equal to 1. Okay, so after we encounter 3, then after that we are obviously going over here because there is only one edge over here, so we are traveling to 1. Now after that we are going to make 1 or the 0th index as 1 in the used vector, and so on and so forth. After we have traversed the entire graph or as many nodes as possible, it will look something like this, right? 1 1 1 and 0 for the last fourth node, right? Because it itself cannot encounter itself, it is not able to encounter itself, right? So if we encounter a particular node twice, we'll just ignore that node and not push it onto the queue, right? Since we are stopping the loop when the queue runs out of any priority queue runs out of any inputs. So if we stop putting nodes which we have already encountered again and again, so even if we detect a loop or we are not able to reach back to 4, eventually the queue is going to become empty, and we'll just exit the loop in case we don't find any value which is returning back to 4 itself. Okay, so this is a scenario for when we are not able to go back to 4. That means we just keep a track of which nodes we have accessed, and if we have encountered that particular node, we'll keep track of that, and after a certain period of time we will stop encountering nodes which we have not encountered, right? And after that point of time we are not pushing those particular what do we call particular nodes onto the queue. So the queue would eventually turn out to be empty, and this 4 and then we would just go out of the for loop, and since we are not able to print a value, so flag would remain as 0 and we would print -1. So this was the basic solution for Martian Life. If you still have any doubts, you can always reach to us on the WhatsApp group. Okay, so let's just run the code once and submit it. Yeah, that was the solution for Martian life.